title of the first chapter is about quadratic functions and equations in one variable. Okay, previously you learned about linear equation, right? Now you are going to learn quadratic function. Anyone can tell me quadratic function, what is the power of the equation for quadratic function? The highest power.
Power
Again?
2.
Yes, very good. You have idea already. So we are going to learn these quadratic functions and equation in one variable. I hope that you understand what does it mean by one variable, two variable right now. Okay, let us look at the picture first. Anyone recognize this picture? The picture in, pardon?
Bridge.
Yes, it's a bridge. And then where is the bridge from? It's actually a little bit different from the picture in your book because I get it from the internet. So this one is about the bridge in Pulau Barisan that is located in Kuala Terengganu. Okay, the island became a new tourist attraction because it is a man-made island connected with a bridge. This bridge is similar to the one in Putrajaya. Okay, do you know that the shape of this bridge has special mathematics characteristic? Do you have any idea the shape of this bridge look like?
Yes.
Yes, right. What do you call it?
The quadratic function.
Okay, you relate it to quadratic functions right away. It actually has the shape of parabola. Okay, so that is what you are going to learn today. The quadratic function that is in the shape of parabola. Okay, so this is working through time. Same thing, when we go through each of the chapter, you will encounter all the mathematicians that involved. So I have to introduce a bit to you when we go through all the chapters. So this chapter, the mathematician involved is Al-Khawarizmi. Okay, so you can read this lah. He is well known as the father of algebra. He was the founder of a few mathematics concepts. His work in algebra was outstanding, and he was responsible for initiating the systematic and logical approach in solving linear and quadratic equations. Okay, so you remember Al-Khawarizmi. I'm sure those who have read him in the history before, you know this Al-Khawarizmi already. Okay, let us look at the next slide. Okay, what is the purpose of us to study this chapter? Okay, you look at the... Okay, good, Haikal. So, quadratic function and equation are widely used in science, business, sports, and others. In sports, quadratic functions are important in sports events such as shot put. You know shot put already, right? What does it mean in Bahasa Melayu? What is the name? Remember or not? Because, yeah, bagus. You have learned that in Form 3. What about discuss? Tahu tak? Dalam bahasa Melayu dipanggil? This one is lempar cakra. You know cakra, right?
Yes.
The one that is something like a piece of thin, what do you call it now? It's the smaller piece of circle thing like this, lempar chakra, that you have to draw as far as you can. And the third one is javelin. You know what is the javelin?
Yes. Lembing.
Rejam lembing, correct. Yeah, so everything over here, when you throw it out, you can see the shape of parabola. That's why they relate it to these quadratic functions. Okay, now the next one here. In architecture, we often see curved structures in the shape of parabola, which are related to the mastery of quadratic concepts. Okay, let us move on here with the word bank. What you are going to encounter with the new word in this chapter. First one is quadratic function. If you don't understand, you refer to the BM version here. Axis of symmetry, I'm sure you know this already. Variable, pemboleh ubah. Root, that is the punca. Then we are going to learn maximum point and minimum point. Okay, so only 6 of the word bank over here. Okay, let us carry on. Now you look at this picture again.
Madam,
Yes.
is parabola a two-dimensional shape or a three-dimensional shape?
Two-dimensional shape only. Okay.
Alright.
Yeah. So this person is kicking the ball. The purpose they are showing this, the person that is kicking the ball is to let you see the shape of the movement of the ball over here. So, have you ever sketched the movement of a ball kicked by a football player as shown in the picture? You ever sketch or not?
No.
No, right?
No.
I think you won't do that, right? If you really want to sketch, you are going to sketch things like comics and so on. So the shape of this movement is a parabola, like we have done earlier, the bridge, the shape of the bridge. Okay, let us carry on here. So in this mind stimulation 1, that is to to identify and describe the characteristic of quadratic expression in one variable. So you are given all the expression down here, okay, with the QR code given. So luckily we are having our online session. I can show you this regarding the GeoGebra graphing. Okay, we are going to go through this one by one, and then we are going to see the shape of the graph of each of these, and we are going to find the coordinate of the lowest or the highest point if there is. So do you still remember how to state the coordinate? Yes or no? Okay, coordinate, you state in the form of what? In bracket?
X and Y.
Yes, very good. X and Y.
Oh.
Okay, let us go through the GeoGebra here. So I will have to type in the formula one by one. I'm going to refer to my book here. The first one, if you have your book there. Just now you're given the expression x squared. So when I am entering the value, you can see what happened to the graph. Plus 4x plus 1. So this is the shape of the graph. It is a parabola, isn't it? So just now, yes, very good. So just now when they asked you to fill in the shape of the graph, it is look like a U shape. So what you do is you just need to fill in here with the shape of U. So I'm going to try to use other color, like this, and then find the coordinate of the lowest or the highest point. So if you look at this one, what is the coordinate? Can you identify or not?
-3, -2.
-3, -2. Maybe it's smaller. You cannot really identify it.
Negative 2, -3.
Yes, very good. -2, -3. So you just need to fill in here. -2, -3. Okay, we try to go through one by one here. So this one is x to the power of -2 minus 1. I'm going to add in one more one. Or I just cancel this one. X to the power of why I can't insert it. Okay, if that is the case, I close it again. Okay, x to the power of -2 and then minus 1. X to the power of -2 minus 1. What does it look like? You have learned this in Form 3, isn't it? The different type of shapes of the equation. You have 4 types of equation. The first one is linear equation, followed by quadratic equation, and then cubic equation, and the last one is the what do you call it already? What is the last one already? Reciprocal. Remember? Have you ever learned that, class?
Don't really remember.
Not really, yeah. If not
Don't really
really, okay.
So I don't remember learning.
You don't remember learning that? Okay, if that is the case, I add in one slide over here for you to see. You have 4 types of graph that you have learned. Huh? The first one is linear graph. Linear graph is a straight line like this. It can be a straight line like this, or it can be a straight line that is going down like this. Okay, this is called linear graph. Second, you learn quadratic graph. So quadratic graph, it can be like this and this only, 2 ways. So this is quadratic. The third one that you learn is cubic graph. This is just a general knowledge, huh? So cubic graph, you will have something like the S shape, something like this, or it can be like this, something like this, huh? And the last one is the reciprocal graph. Reciprocal will be something like this. Okay, or it can be this way here. 4 types of graph. Okay, so the one that we have seen just now, I discard this one now. This one. Can you identify this is under which one?
Reciprocal.
Reciprocal. You are right. Very good. So you was listening to me just now. So this one is reciprocal graph. Okay, let us move back to fill in the answer for this one. Huh? Okay, so this one is like this, the shape of graph. And then, can we find the lowest or the highest point from that graph here? Sorry, not this one. Cannot, right? We cannot find the highest and the lowest point because the highest is infinite and the lowest one is also infinite down here. We don't know what is it. It could be -1, but we cannot have the precise value. Like just now, we have one certain point over there. Okay, but this one is uncertain. So we just put a dash there. Okay, now we look at the next one. -2x squared minus 2x plus 5. So I'm going to fill in this one. -2x squared minus 2x. So you can see the shape now is changing. Plus 5. -2x squared. I missed out this x. So when I put the x in, it directly changed to a parabola. Can you see? It's a U shape or the reflection of U? Reflection, right? It looks like something like N. Okay, now we need to identify this point. This is the highest point. So if you look at the highest point over here, it's pointing at 5 point something, right? This is 5.5. This is y-axis. And the x-axis is pointing, I make it smaller, here. Maybe you can see clearly. Okay, it go back. Sorry, I don't know why it goes. Hilang pula, lost already. -2x plus 5. Okay, so the point, I think you can't really see the point over here, but if we really want to read, this is the highest point. Just now it's positive 5.4, right? So you look at my arrow down here. Can you roughly guess how much is this point?
Yeah, 0.5.
Because this is 0, this is -2, so most probably this is
-0.5.
Yes, very good, -0.5. So we assume it is -0.5 and also 5.4. That is the coordinate of the y-axis just now. Okay, and the shape is like this. Okay, now can you guess the next one? D here, 5x plus 4. What is the shape of the graph? Can guess or not? Yes, you may, Diana.
Straight line.
Yeah, very good, because you have learned that already, right? 5x plus 4 is a straight line. So you can see from here, I'm add in 5x plus 4. You see this orange color is a straight line. Okay, so we go back there directly, we just put it a straight line. And then the coordinate of the lowest or the highest point, we don't have for this one. Okay, 3x squared minus 2. Can you imagine or can you guess what is the shape of the graph? If cannot, then we show it to you. 3x squared minus 2. The one in blue, so I minimize it a bit. Okay, the one in blue. So it is another quadratic graph that is U shape. Okay, go back, we fill in the shape. Now we need the coordinate of this one is the lowest point. So the coordinate is 0 and negative 2, correct. So just fill in 0, negative 2. And the next one, negative 2x squared plus 4x. Now, out of this that you have done, can you guess this f here, expression f? What is the shape of the graph? Can you guess?
It's a shape, but
Reflections of you.
Yes, very good. It looks like an N. Some of you already can guess it. So I repeat, this is N. And then this one, I don't have to go through one by one. We need to save the time. You just look for the highest or the lowest point. If you have this shape, you will get highest or the lowest point. Highest because it's on top. If you get the U shape, you will get the lowest point. Okay, now we look at G. X cubed plus 1. What kind of graph is this?
S. It's not.
Let me show it to you because it's still new to you. Okay, I input another one. X cubed plus, plus 1. Which is the one here? Px. X cubed plus 1. Okay, I think I have to erase the rest. And then minimize it. X cubed plus 1. This one is a mistake here. X cubed plus 1. What kind of graph is this?
A cubic graph.
Very good, because it looks like the shape of S. So just now in the beginning, I've told you 4 types of graph, right? If they look like this is a cubic graph. Furthermore, the value of the x, the power there, is a cube. So the shape look like this. And the coordinate of the lowest or highest point, we don't have. Okay, so we have seen the 4 types of graph over here. The first one, the third, and E and F over here, these are all the quadratic graph. This is the one that we are going to see. And the reciprocal, the linear graph, the cubic graph, we are not going to enter this part. This is just for your knowledge only. So there's 2 things that I want you to memorize here. When you look at the shape of the graph for a quadratic graph, it can be U shape and the N shape only. When will it become U shape? When the value of the x squared over here, when the value is positive. This is a 1, positive, right? So you can see when it is positive, you get U shape. Here is 3, positive, right? So you get U shape. When you get an N shape, meaning that the value of the A here is negative. So we have negative 2, and the next one, negative 2. Whenever you have the value of A is negative, you are going to get N shape. Okay, we are going to further explore about this later on. Let's look at the next slide here. Okay, a quadratic expression in one variable is an expression whereby the highest power of the variable is 2. So now you are going to learn on how to identify a quadratic expression. Okay, the general form of a quadratic expression is ax squared plus bx plus c. For this, you have to memorize. That is the general form for a quadratic expression. So a, b, c, you just add on the x squared and x in the middle here. Ax squared plus bx plus c. You memorize it right now, huh? Then, you got to know whereby the a, the b, and c are constant. Constant means it is a number here. Like just now, we have 4x squared plus 2x plus 5. So you can see the value of the a, b, and c are all number. But with the condition of the a cannot be 0. Why the a here cannot be 0?
I know, teacher.
Pardon?
I know.
Why?
Why? Because when a is no longer equal to 0,
Yeah.
it is no longer a quadratic
Expression. Yes, very good. When the a becomes 0, so it will be 0 times x squared. Anything multiplied by 0, it becomes 0, right? So the 4x squared becomes nothing else, it's gone. So it becomes a linear expression already. Okay, so very good, you understand that. Okay, then we look at the next thing here. Here, we have x squared plus 2x minus 1. Okay, we are going to check that they are the quadratic expression because it follows the general form of this here. X squared plus bx plus c. Can you see that? Ax squared plus bx plus c. Same with the second expression here, negative y squared plus 3y. Although there's no c there, okay, but it is still considered a quadratic expression. And then we look at the third one here, 1 over 3 m squared minus m plus 4. So instead of using x and y, you can also use other variable, but it must be the same. Okay, so this one is also a quadratic expression. And the next one, 2n squared plus 5. So we have the ax squared plus c. Although there's no bx in the middle, but as long as the power of the variable is 2, then it is still considered a quadratic expression. So now I have a question for you. If I said 3n squared only, is that a quadratic expression?
Yes.
Yes, it is very good. So now let us move on. On this example, we are going to determine whether each of the following expression is a quadratic expression in one variable. If not, then you justify your answer, meaning that you have to give explanation. Why do you say so? Okay, first one, A here. 2x squared plus 5. Is it a quadratic expression in one variable? Yes, it is a quadratic expression in one variable because it fulfills the general form, right? Which is x squared plus c over here. Okay, so this is a yes. B, x cubed minus 6. No. Okay, so justify your answer. Why do you say so?
Because the
Highest power of variable is
Yeah, very good. Because the highest power of the variable here is 3. So this is not a quadratic expression. Okay, we look at C here now. 3x squared plus 2y plus 1. Is it a quadratic? Okay, why no?
It has two variables.
Very good. Because it has two different variables over there. So the answer is a no. And then D, I'm sure you know already, right? Yes or no? Yes, it is. Okay. E, 2x squared minus 3 over x squared. Yes or no? Why no?
Because the second one has x squared.
Okay, if I give you 1 over x like this, 1 over x squared, can you tell me how much is the power of the x?
2.
Is it 2? Is it the same as it becomes negative 2, right?
Negative 2.
Yeah, so we cannot accept this one because the power of the variable is negative 2. But to explain this question is a bit different from the rest. You have to say that because one of the variable, the power, is not a whole number. Here, it's not a whole number. Okay, but we know that as long as you have 3, 4, 5, 6, it's not a quadratic expression anymore. Okay, same with question F over here. So this one is a no. F here, can you see this one? Okay.
Yeah.
Can you see this x to the power of 1 over 2?
Yes.
Okay, yes, right. Now, can you tell me whether it's a quadratic expression in one variable or not?
No.
No. The reason?
This is a whole number.
So it's the same as this one because the power of the variable here is not a whole number. So if you refer to your textbook, this is their explanation. These two, they are having the same answer because there is a variable with a power which is not a whole number. Okay, now we carry on. This is another mind stimulation 2. So the aim is to state the value of A, B, and C. After you know how to state the value of A, B, and C over here, we are going to stop because our lesson is up to 10:30 only. So if you refer to the quadratic expression, it's very simple. We know the general form already. Remember the general form?
Yes.
What is the general form, class?
Ax squared plus bx plus c.
Very good. Yes. Ax squared plus bx plus c. So what you do is you just need to compare with the general form to determine the value of A, B, and C. So same with this first expression, they give you the example already. 2x squared minus 3x plus 1. So you arrange it properly like this and then you compare the value of A. So the A is 2. The B is negative 3. So B is negative 3 here. And the C is 1. You get that or not?
Yes.
Yes. Okay, let us try out some of the example given. First one, 2x squared minus 4. So they give you the general form here. You just need to fill in 2x squared minus 4 at the back. What is the value of A?
0.
It's 2. Okay. What is the value of B?
0.
Yeah, because there's nothing here. And then what is the value of C?
Negative 4.
Yes, easy. Okay, can I call your name and you answer one by one?
Yes.
Since a lot of you know how to answer already. Okay, you just need to compare with the general form here. So 1 over 2x plus 5x minus 3 over 2. So I'm going to just pick you randomly. See who is the lucky one today. Idly Shami. Are you there? Okay. Idly, what is the value of A here?
1 over 2.
Yes, very good. 1 over 2. Okay, I'll choose another one so ID can answer me. Alia Farisha.
Yes, madam.
Okay, what is the value of B?
5.
5. Very good. I jot down here while you are answering my question because I told you I'll give you merit already. So they have their merit already. Now, next person. Afin bin Amiruddin. Afin, are you there?
Yes, madam.
Okay, what is the value of
3 over 2.
Wow, great. You got it right. Negative 3 over 2. Okay, next person. Grace Hannah. Grace, are you there?
Yes, madam.
Okay. From this expression, we are looking at D right now. Negative x squared plus x. Can you tell me what is the value of A?
0.
The value of A. You need to compare with A, x squared plus B, x plus C. So you see the x squared is here. Then,
Yes.
what is the value of A?
Negative x.
It's actually negative 1.
Negative 1.
Negative 1, okay? Can or not?
Can.
Okay. Grace again, since you got the first one not correct, but you almost get it already. Now, you see this x, you compare with bx. Okay, so what is the value of b, Grace? If there's nothing written.
1.
Correct. It's a 1. You remember last time when you learned the variable, if the x without anything, it means this is a 1. Unless I write 2x, then the value or the coefficient is equal to 2 and so on. Understand, huh?
Okay.
Okay, so next person. Kaisara, are you there? Kaisara Nabila.
Yes.
Okay, Kaisara, what is the value of C?
0.
Yes, good one, Kaisara. Then I move on to for Ruby now. Dania Khadija, are you there?
Yes.
Okay, what is the value of A for this expression here?
-1.
Yes, it's the same as the one on top just now. Very good. Dania Khadija, done. Next person. Fahrin. Fahrin, are you there?
Yes.
Okay, Fahrin, what is the value for B?
-3.
Yes, good one. Okay, next person. Hazim Izuddin. Are you there?
Yes.
Okay, what is the value of C?
-9.
Wow, great. -9. It seems like most of you can answer it already. So we have 3 more left here. 1/2x squared only. Aida Farida?
1/2.
Yes, the value of A is 1/2. Okay. Next person. Putri. Putri?
Yeah.
Okay, what is the value of B, Putri?
0.
Yes, you are right. Very good. Next person. Zul Fahim. Are you there?
Hello, ma'am.
Okay, what is the value of
Yes.
C, Fahim?
0.
Yes, you all got it right already. Anyone don't know how to get the value of A, B, C here? Still don't understand? Nana, if you don't understand, you raise up your hand. Huh? Okay, so I think most of you understand on how to get it already. Hold on. I have to start first. Now, we just need to look at the next slide here. Okay, so from the activity just now, we know that all quadratic expression can be written in the form of ax squared plus bx plus c, whereby the value of a cannot be 0. Okay, so in a quadratic expression, a just now is actually the coefficient of x squared. For example, the first one, 4x squared minus 2x plus 3. So the a is the coefficient of x squared. You have learned the word coefficient since form 1 already. X squared, the coefficient of x squared is 4. If you look at this second, the number bx here, the coefficient of x is -2. That is how you determine it. So you can see a and b are the coefficient of the x squared and also x. But when it comes to c here, c is a constant. Okay, so why do we call the c is a constant? The c here. Why?
Because it is a number.
Very good, because it is a number. So you all know that already, right? Remember, to find out the coefficient, to find out the value of a and b, you just need to refer to the coefficient of it. The coefficient of it, and the last one is a constant. Okay?